An important part of our UCS networking environment is going to revolve around how the Fabric Interconnect does its switching. We remember that it's running in end host mode, and so it's not doing traditional switching, and it has to sometimes know how exactly to handle certain situations. Now, in this video, we want to explore a couple of things. First of all, we've got these uplinks going from the Fabric Interconnects to our traditional network, and we know on traditional network links we can restrict VLANs and such, and so we need to understand how we're going to do that, and we're going to use VLAN groups in order to accomplish it in UCS Manager. Now, the other thing we want to consider is the fact that we've got all of these VNICs down in the server layer, and they're all pinned to individual uplinks upstream. So by default, UCS will automatically handle that, but what if we want to manually pin that? And that's where LAN pin groups are going to come into play. Let's dive in and take a look at these two different mechanisms. Let's start with the concept of VLAN groups. In our environment, we're going to have a pair of Fabric interconnects, and these Fabric interconnects, remember, they're going to look like switches and act like switches, but they are running in end host mode. End host mode says that we're going to learn MAC addresses downstream, but we are not going to learn them upstream. Now, when we have our uplinks connected to the local area network, again, we're familiar with this idea of logging into a Nexus switch. I can get onto NXOS, and I can get onto an interface, and I can say switch port, trunk, allowed. I can say I'm only going to allow, let's just say VLANs 10 through 20 on here. And then I can also get on here and say switch port, trunk, native. I can specify what the native VLAN is going to be. Maybe I want the native VLAN to be 10. And so this is my CLI configuration. How exactly am I going to apply this to these interfaces? Because I've got the exact same concept on these Fabric interconnects, so yet I don't have CLI access to the NXOS side of it. Now the good news is if we don't need to restrict our VLANs, all of the VLANs are going to be allowed by default. So all VLANs will be forwarded upstream. We don't need to worry about the Fabric interconnects just manually pruning VLANs that we didn't want them to prune. All of the VLANs will be allowed. And then the question, of course, is, well, what if we don't want all the VLANs on all of the uplinks? Well, then we need to use VLAN groups. The idea of VLAN groups is to do exactly what we're doing over here on the right. We want to be able to control the VLANs that are on these links as well as the native VLAN. Now, creating a VLAN group is pretty straightforward. We're going to go onto the LAN tab, and then we're going to create our VLAN group. Now, we have two steps to creating a VLAN group. First of all, we select the VLANs. This is a series of checkboxes. If I want VLAN 10, I check that box. If I want VLAN 11, I check that box. I pick all of the VLANs that I want in my environment, maybe all the way down to, let's just say, the example that we used over here, all the way down to VLAN 20. But then I also need to select the native VLAN. That'll be a radio button over here, so the native VLAN option is going to exist for all of them, but of course I can only have one VLAN that's the native, and so I'm going to pick VLAN 10 to be the native in this situation. So that's the first step. The second step is then to pick which interfaces to apply this VLAN group. So if I want, for example, VLANs 10 through 20 on the left interface, we'll just call this Ethernet 1/1, and then maybe I want a different set of VLANs, let's just say 5 through 15 on Ethernet 1/2. I'm not sure why I'd have this configuration in my environment, but hey, why not? So I will go down here and I will specify Ethernet 1/1. Now this can be a standard interface or it can be a port channel interface if I have port channels configured as well. And just by creating this VLAN group, it's going to map these VLANs and this native VLAN, by the way, with the set of interfaces that I choose. And so I will create one VLAN group for the interface on the left. I'll go through this process again. I'll select the VLANs, I'll select the native VLAN, and then I'll apply the second configuration over to interface Ethernet 1/2. Now, one of the best ways we can validate that this configuration has taken effect is to get onto the CLI of the Fabric interconnect. Now, once we're on the CLI, the first thing we're going to want to do is enter the command connect NXOS. Connect NXOS changes the nature of the CLI session to now be on NXOS. So I'm going to see this as if it's a traditional NXOS switch. I'm going to have the standard looking prompt, at which point I can enter my traditional command. In other words, show run interface. So I'll say show run interface Ethernet 1/1. And this is going to give me the standard rundown. It's going to show me switch port trunk allowed. It's going to show me switch port trunk native. It's going to give me all of the interface configurations that I've created at this point on that interface. And so I can validate that my allowed statement says 10 through 20, which is what my VLAN group was configured to accomplish. I can also validate that my native VLAN matches up what I had circled here, which I had chosen via that radio button. And so this process right here of connecting to the NXOS side of the CLI is going to be immensely beneficial for us as we're building out the networking inside of UCS. Now, the other functionality we want to talk about is the idea of LAN pin groups. This is going to come back to the idea that the Fabric interconnects are running in end host mode, and we're not actually forwarding like a switch, we're using the concept of pinning. Now, pinning is based on a VNIC perspective, so our VNIC right here is going to be attached to a virtual Ethernet port, which we talked about in the last skill, and that virtual Ethernet port is the one that's going to get pinned to a particular uplink. Now, by default, UCS is going to use dynamic pinning. Dynamic pinning says that I'm just going to grab a virtual Ethernet interface. I'm going to look at all of my eligible interfaces. So I might have a lot of interfaces. Some of these might be port channels. And when I say eligible, by the way, what I really mean is the number of VLANs that are on it. If this virtual Ethernet interface has been configured for VLANs 10 through 20, for example, maybe the first three all have VLANs 10 through 20 on them. That would make them eligible. However, maybe this last interface, it's only got 10 through 15 for whatever reason. Well, that means that it's not eligible. Now, because it's dynamic, it's just going to pick one of these, call it at random. It's got a methodology for how it determines that. It's going to attempt to load balance the virtual Ethernet interfaces out the different uplinks. But at the same time, we can't determine that. I can't tell you for sure that this virtual Ethernet interface is going to show up on this upstream Nexus interface, whatever this interface is here, or possibly this one. It's going to show up on one or the other. Now, LAN pin group is all about this concept of static pinning. It's the idea that I want to determine for myself which VNIC is pinned to which uplink. The LAN pin group is going to be configured globally, but then I apply it to a VNIC. And so as part of the VNIC configuration, it's going to allow me to say, hey, you're pinned out this uplink now. Now, when I create the LAN pin group, really truly all I'm doing is selecting interfaces. And I get to select an interface in Fabric A, and I get to select an interface in Fabric B. Because I don't know which of my VNICs are going to be mapped to this LAN pin group. It might be on Fabric A or Fabric B. So in my example here with the VNIC on the right, this is mapped through Fabric B. And we do recall, by the way, that our VNICs are only mapped to one fabric at a time. Because it's on Fabric B, it's going to use this LAN pin group and look at the interface that was configured for Fabric B. Now this interface could be, just like before, a standard interface, or it could be a port channel. But either way, it's specifying some kind of logical connection upstream of the Fabric interconnect. Now it's worth noting, by the way, that let's say I pin this VNIC to this link over here on the left. I'm coloring it in as orange. So now this VNIC will always go out that interface. Our inclination might be to believe that we have now reserved that link for the VNIC, but that's actually not the case. We could have another 20 or 100 or 200 different VNICs out this Fabric interconnect, and they're still going to be load balanced between links 1 and 2. And so this VNIC here is statically pinned to the link on the left, but that link is not reserved for that VNIC. Now the other concept in all of this that we need to think about is the idea of failover. If we are using dynamic pinning is going to automatically fail over. Meaning that if I have a VNIC over on this side, let's just say, so this VNIC is using automatic pinning. So it gets pinned to the link on the left, but then something happens with that link and it goes down. Well, because I used dynamic pinning from the beginning, it's going to get automatically repinned to the link on the right, assuming that link is an eligible link, meaning it has all the VLANs that are required for that VNIC. And by the way, it should be noted that the Fabric Interconnect is going to send a gratuitous ARP upstream, otherwise known as a GARP. That's going to tell the rest of the network that, hey, all of the MAC addresses that used to live out this link now live out the new link. We need to make sure that the network knows where all of the MAC addresses are so it doesn't have to relearn that. However, if I go to static pinning is going to rely on the concept of fabric failover, meaning that I can't actually move like VNIC off of the link that just went down on this fabric. Therefore, as far as the VNIC is concerned, the VNIC sees that fabric as being down. Because the VNIC thinks that fabric is down, if I don't have fabric failover enabled, then that VNIC just goes into a down state. And maybe that's fine. Maybe I've got redundancy through the other fabric already via a second VNIC. If, however, I do want this VNIC to stay online, well then at that point I'm going to need to configure it for fabric failover. Fabric failover tells the VNIC and tells the FIs that, hey, I'm also going to have a virtual Ethernet interface out the other Fabric interconnect, just in case I need it. And because I lost my pinned uplink, my statically pinned uplink on Fabric B, I'm now going to swing over and use my connection on Fabric A. So as we see here, the VLAN groups are going to allow us to restrict our VLANs just like on a traditional NXOS interface. We can choose the number of VLANs and we can select the native VLAN. And we can confirm that by looking at the Fabric Interconnect CLI. Next, we have the LAN pin group concept. So our VNICs start off dynamically pinned, and that allows for dynamic failover and everything. However, if we want to force our VNICs to go out a particular link, we have to use static pinning. And we do that by way of the LAN pin group, which allows us to statically map a VNIC to a particular interface. But again, from a failover perspective, we're going to need to rely on fabric failover at that point if that link were to go down. I hope this has been informative for you, and I'd like to thank you for viewing.